So in this video, we're going to go over how to determine the intervals over which a function is positive or negative. And the basic idea is we are wanting to establish the input intervals. What are the inputs for which the function generates either positive outputs? To be greater than 0 means to be positive, or identify those intervals or those input values for which the function is negative or less than 0. So what we want to remember that is that in function notation, our inputs are our x's generically. That's our generic input. And f of x represents function output. So if we're saying, hey, what are the values of x for which the function is greater than 0? We're really saying when are the outputs positive? And if we're saying what are the x values or input values that generate for which f of x is less than 0, we're saying, hey, what are the values of x? Or what are the intervals over which the function outputs are negative? Because to be less than 0 means to be negative. And then what we want to remember kind of as a key concept is that 0 is neither positive nor is it negative. It is the number that separates the positive numbers from the negative numbers. So if I want to know when are the outputs positive, I'm really referencing the function with respect to the y-axis or the vertical or output axis. We plot our outputs or our f of x's on the vertical axis. So on the vertical axis, to be positive, I wouldn't include the 0, and any numeric result above the x-axis will be a positive result, because as we move up the y-axis, we're moving towards infinity. So if I'm asking when is f of x greater than 0, I'm asking when are the outputs positive. And that's going to occur anytime the graph of the function is above the x-axis. So I think kind of the first step in determining the intervals for which are positive is to run along the x-axis, and say when are the outputs 0. So here I have an output of 0, here I have an output of 0. And then I want to use those zeros to describe the intervals for which the function is above the x-axis. So as I move from negative infinity along the x-axis towards this place where the function output is 0, I see that the function is everywhere above the x-axis over that interval. So I start off by saying, hey, the function is greater than 0 or positive as long as x is an element of, we're coming from negative infinity. We see that the function is above the x-axis, which means our outputs are on the positive y-axis, up until this point where we get an output of 0. And that's occurring at, it looks like, -4. So we run along until we get to -4. And as long as we're on that interval, our function's above the axis. We can't include the 4 because at -4, the function output is 0, and 0 is not a positive number. It's neither positive nor negative. And as I run along, I see when I get to this point right here, which looks like it's at +4, the function once again is above the x-axis, where the output values are going to be plotted on the positive, or with respect to the positive y-axis. So I'm going to go union, now pick up at 4. Again, I can't include the 4. I can't go square bracket include the 4, because at x equal 4, the output is 0. This point right here is the ordered pair input 4, output 0, and 0 is not positive. So we're going to go open parentheses, pick up at 4, and then, well, we're not headed to infinity, so here, instead of an arrow, I have a closed dot saying the function truncates here, and it's truncating at the point input 5, output 5. So I know at 5, which is the last input value for my function in the positive direction, I do get a positive output. So I'm going to say from on the interval from 4 to 5, I have positive outputs. And I do include the 5 at this point, because at 5 I get a positive number or greater than 0 output of +5. So these are the intervals over which my function is positive. My function is negative or less than 0. Well, that's going to occur when we're below the x-axis, because if I put an open circle at 0 and on my output axis I run an arrow going down towards negative infinity, anywhere where the graph is below the x-axis, we're plotting our outputs with respect to the negative y-axis or negative output axis. So where is the graph below the x-axis? Well, that's going to occur when x is an element of the interval. We start at -4. Again, we don't include -4 because at -4 the output is 0, and 0 isn't a negative number. And we run all the way over to x equal to 4. We have the ordered pair 4, 0 right here. We don't include the 4 because at 4 the output is 0, which isn't negative. So as long as x is on the interval from -4 to +4, our function is negative. So we do one more example, and this one has a couple subtleties in it. But I'm going to do the same thing essentially that I did before. I'm going to sweep along and say, hey, if I want to know where my function is positive or negative, I'm going to find where the function outputs are 0, because those we know 0 isn't positive nor is it negative, so those are going to be places where transitions happen, or those are going to be places where we have to take into consideration the fact that we have an output of 0. So this looks like it's the ordered pair -2 output 0. This looks like the ordered pair right here. We're counting by 2's, 2, 4, that's input 4, output 0. And this ordered pair right here is input 8, output 0. So as we run along the x-axis, up until we get to x equal to -2, we see that the graph of the function is below the x-axis, and the arrow on the function right here indicates that we went infinitely far to the left towards negative infinity on the input axis, and that we're going infinitely far down towards negative infinity on the y or output axis. So as we run along from negative infinity up to x equal to -2, right here, the graph is below the axis, so we have a place where our function is less than 0 or negative. So the intervals over which my function is negative, I'll say, hey, x is an element of, we're coming from negative infinity, we're running up to -2, but I can't include -2 because at -2 the function output is 0, which isn't a negative number, so I have to exclude it. And then union, I'm going to pick up the next interval. Immediately the function goes down below the y-axis again. So immediately at x equal, once I get past x equal to -2, the function outputs are still negative all the way up until I get to an input of 4. I can't include the 4 because at x equal to 4, the function output f of x equals 0, f of 4 equals 0. And then the function never goes below the x-axis again. So I know that the function will never be negative again. Then I can ask the question, when is the function greater than 0? Or in other words, when are the function outputs positive? And that's going to occur whenever the graph of the function is above the x-axis. The first place that's going to happen is going to be just past 4. So 4 is that boundary where the outputs are neither positive nor negative. So I start at 4. I'm above the x-axis. I get to 8. And I need to exclude 8 because at 8 the function is not greater than 0. It's actually equal to 0. Union. And then the function immediately raises above the x-axis again. So from 8 to, and there's an arrow here indicating that the x values are going to infinity. So on the interval from 8 to infinity, my function will be positive. We could ask we could ask the question, where is f of x equal to 0? And then for this I would actually use set notation, because there's a very easy to list finite set of places where that happens. The function is equal to 0 when x is -2. It's not an interval. It's just at -2 it's 0, at 4 it's 0, and at 8 it's 0. So here, if I wanted to say where the function was actually equal to 0, I would not use interval notation, because it's not 0 over any intervals. It's equal to 0 at discrete values of x. We could do one more thing, just to shake things up a hair. We could say, when is f of x less than or equal to 0? And then this would change the game a little bit, because I'm less than 0. If I put that less than or equal to sign on there, I go x is an element of the interval. I'd be starting at -infinity. When I get to -2, which I had to exclude before when I was doing, where is the function negative? Here, the moment you say, hey, when is it equal to 0? Well, you get to keep the -2, because at -2, the function outputs 0. Now I'm still negative. Now I'm at 4. And at 4, the function value is 0. So I actually would say that the function is less than or equal to 0 on the interval from -infinity all the way up to 4, and including the 4. And then we'd be unioning this with this one little spot. This one little spot where the function output is 0 again. Hey, maybe that's the closed interval from 8 to 8. There's a funky way of just saying, hey, at the value of 8, the function output 0.